Venus hangs in Earth's sky as the brightest point of light after the moon, a jewel wrapped in cloud. For centuries, astronomers imagined a warm, twin world beneath that veil. Perhaps swamps, perhaps oceans, perhaps life. The reality is one of the most hostile environments known to science. The surface temperature reaches roughly 465 degrees Celsius, hot enough to melt lead and glow faintly in the dark. The atmospheric pressure at ground level is about 90 times that of Earth, equivalent to standing nearly a kilometer beneath the ocean. The air itself is almost entirely carbon dioxide, thick as syrup, laced with clouds of sulfuric acid that drift kilometers deep. No human machine of the 1960s was built to endure such conditions. To photograph the surface of Venus was, by every reasonable measure, impossible. And yet a single photograph from that surface would answer questions no telescope on Earth could reach. The clouds are permanent and total. From orbit, from Earth, from any vantage point, Venus shows only a blank yellow-white shell. To know what lay beneath, an object had to descend through 50 kilometers of crushing, corrosive atmosphere, survive the heat, and open an eye long enough to capture light. The Soviet Union set itself precisely this goal. Beginning in the early 1960s, engineers at the Lavochkin Design Bureau built a series of probes named Venera, the Russian word for Venus. Their ambition was staggering, not merely to reach Venus, but to land on it and send back a picture. Every instinct of physics argued against them. A vessel strong enough to resist 90 atmospheres would be heavy. A vessel light enough to launch might be crushed like a tin can. The heat would fry electronics within minutes. The acid would eat at seals and lenses. The engineers faced a planet that seemed designed to destroy anything that touched it. To take a single frame from that furnace would require a machine engineered to die, and to accomplish everything before it did. Before any lander could succeed, the Soviets would first have to lose a long line of probes to the atmosphere itself. The learning came at the cost of failure after failure. Venera 1, launched in February 1961, fell silent 7 million kilometers from Earth and sailed past Venus dead and blind. Venera 2, in 1965, also lost contact before returning data, but it was Venera 3 that marked a grim milestone. Launched in November 1965, it crashed into Venus in March 1966, becoming the first human object to strike another planet, and revealing nothing, its systems already destroyed. Then came Venera 4 in 1967, designed to descend by parachute and radio measurements as it fell. It transmitted for about 94 minutes, sending back temperatures and pressures that shocked its designers. The instruments recorded conditions climbing far beyond anything expected. Engineers had built the capsule to survive around 25 atmospheres. Venus offered 90. Venera 4 was crushed long before it reached the ground, its final readings taken from an altitude of roughly 25 kilometers, still high in the atmosphere. The data was a revelation and a warning. The Soviets had catastrophically underestimated their enemy. Venera 5 and Venera 6, launched in 1969, were reinforced, yet both were flattened at similar altitudes, transmitting for less than an hour each before the pressure won. Each failure carved the true shape of Venus into the engineers' understanding. This was not a warm twin. This was a pressure cooker, deep enough to drown a submarine. The atmosphere did not thin as one descended. It thickened relentlessly, a rising wall of heat and force. Every probe that died added a number to the equation. This deep, this hot, this heavy. By 1970, the goal was no longer simply to reach the surface, but to build something that could withstand the impossible. Venera 7, launched that year, finally transmitted from the ground in December 1970, though it landed on its side and returned only faint temperature data. It proved a machine could touch Venus and briefly live. But a photograph remained a dream. The graveyard of crushed capsules had taught one clear lesson. To photograph Venus, the Soviets would have to build a sphere strong enough to survive hell. The answer to Venus was a shape as old as geometry, the sphere. A spherical pressure vessel distributes external force evenly across its entire surface, with no weak corners or flat panels for the atmosphere to buckle. The Venera landers were built around titanium spheres, forged and welded to resist pressures near 90 atmospheres and beyond. Titanium offered strength without unbearable weight, though the vessel still weighed hundreds of kilograms. Inside this armored shell, engineers packed the fragile brain of the machine: cameras, transmitters, sensors, and batteries, all doomed to fail once heat crept in. So the entire strategy became a race against temperature. Before launch, the internal components were pre-cooled, chilled deep so they entered Venus with a reservoir of coldness to spend. The sphere was wrapped in thick, thermal insulation to slow the inevitable transfer of heat. Some designs circulated coolant. Some relied on materials that absorbed heat as they changed phase. Every gram of insulation bought seconds of life. The landing itself demanded its own choreography. The probes entered the atmosphere at enormous speed, shielded by an aeroshell against the searing friction of entry. Parachutes deployed high up, then, in later designs, were deliberately released so the lander could fall faster through the upper atmosphere and reach the surface before its coolness ran out. Near the ground, a broad metal disc and a crushable ring absorbed the impact and stabilized the sphere. The camera systems were engineered to peer out through small quartz windows, able to withstand pressure and acid. Protective caps covered the lenses during descent and were ejected on landing. The engineers accepted a brutal truth: nothing they built could survive Venus for long. So they designed deliberately for a short, doomed life, an hour, perhaps two, in which the machine would work furiously, photograph, measure, and transmit everything before the heat seeped through and killed it. Success was not survival. Success was accomplishing the mission in the minutes before destruction. With spheres forged and electronics chilled, the Soviets prepared their most ambitious attempt yet. On October 22, 1975, Venera 9 began its descent toward the surface of Venus. Venera 9 had launched from Earth on June 8, 1975, a heavy craft in two parts: an orbiter to circle Venus and relay data, and a lander to plunge to the surface. After a journey of more than 4 months, the spacecraft arrived. On October 22nd, the lander separated from the orbiter and began its fall, while the orbiter maneuvered into position overhead to catch whatever signals came from below. The descent was a controlled violence. The lander struck the upper atmosphere at high speed, its aeroshell glowing as friction tore away the entry energy. Then the shell split, and parachutes bloomed to slow the sphere. As it sank deeper, temperatures climbed and pressure mounted, exactly as the graveyard of earlier probes had warned. The atmosphere thickened around the vessel like water closing over a stone. At a planned altitude, the lander shed its main parachutes deliberately, choosing to fall faster through the lower, hottest layers rather than linger and cook. A ring-shaped disc atop the sphere used the dense air itself to brake and stabilize the descent. Inside, the pre-cooled electronics counted down their borrowed time. Every second in that furnace was a second stolen from the mission's tiny lifespan. The lander touched down on the slopes of a region that would later be studied as rocky, uneven terrain. It came to rest upright, its instruments alive, its transmitter reaching up to the orbiter passing above. The moment of landing was the moment of maximum tension. Would the camera work? Would the protective lens cap eject as designed? Would the sphere hold against 90 atmospheres pressing on every square centimeter of titanium? The mechanisms fired. The cover blew clear of the camera window. Light from the surface of another planet fell onto the sensor for the first time in human history. The lander began to scan, sweeping its photometer across the alien ground, building an image line by line, and pushing the signal upward to the orbiter racing overhead before it vanished below the horizon. In those first seconds, humanity was about to see something no one had ever seen: the surface of Venus itself. The image arrived on Earth as a strip of data, decoded into a black and white panorama that astonished everyone who saw it. For the first time in history, a photograph had been taken from the surface of another planet. The picture showed a landscape of flat, angular rocks scattered across the ground, extending toward a horizon visible at the edges of the frame. The stones were sharp-edged and fractured, some of them broad slabs, suggesting a surface that was relatively young geologically, not yet worn smooth by the ages. Scientists had half expected a blurred, dust-choked murk, imagining that light could barely penetrate Venus's thick clouds. Instead, the photograph revealed something unexpected. Daylight. Enough sunlight filtered down through the 50-kilometer blanket of atmosphere to illuminate the scene clearly, comparable, engineers estimated, to an overcast day on Earth. The camera did not even need the floodlight it carried for backup. Venus, for all its hellish heat, was not a world of darkness. The rocks told their own story. Their fractured, layered appearance hinted at volcanic activity, and a surface shaped by geological forces still at work. There was no sign of erosion by wind or water in the way Earth's rocks are worn. Instead, the stones looked freshly broken, as if the terrain had been formed and disturbed in the not-too-distant past. Part of the lander itself appeared at the bottom of the frame, a curved edge and a tooth component, giving scale and grounding the alien scene in the reality of the machine that captured it. This single strip of pixels rewrote what humanity knew. It transformed Venus from an abstraction hidden behind clouds into a place, a real, rocky, sunlit surface that a camera could stand upon and record. It proved that the impossible photograph was possible after all, that a sphere of titanium and chilled electronics could survive long enough to open its eye and look. But the machine that took this picture was already dying. From the instant it landed, heat had been seeping through the insulation, climbing toward the electronics inside. Venera 9 had only minutes to live, and the countdown had already begun. The moment Venera 9 touched down on October 22, 1975, a countdown began that no engineer could stop. The lander was already dying. Inside its titanium sphere, pre-cooled to near freezing before entry, the temperature climbed relentlessly. Venus pressed in from every direction at 90 times Earth's atmospheric pressure, and its 465-degree heat seeped through insulation designed only to slow the inevitable. The mission had never been about survival. It had been about stealing minutes. For 53 of them, Venera 9 held. The lander transmitted its data through the orbiter passing overhead, a relay station that captured the images and telemetry before Venus could erase the achievement entirely. Instruments measured the crushing environment. The pressure gauges confirmed roughly 90 bars. The thermometers read temperatures that would melt lead. A photometer recorded the strange brightness of the surface, revealing that despite thick clouds, daylight reached the ground with the intensity of an overcast Moscow afternoon. The camera scanned its single arc of the horizon, mechanical shutters and rotating mirrors working in an oven that should have destroyed them. Engineers in the control room watched the clock more than the data. Every additional minute was a gift, a triumph over physics. Then, precisely as the models predicted, the electronics began to fail. Heat penetrated the last defenses. Circuits that had been chilled to buy time surrendered to Venus. The signal weakened, faltered, and after 53 minutes fell silent. The graveyard of probes had claimed another lander, but this one had accomplished the impossible first. It had photographed the surface of another world, and lived long enough to send the picture home. The Soviet engineers understood immediately what they had, and what they still lacked. Venera 9's single black and white image was monochrome, limited, a keyhole glimpse. It proved the method worked, but it left the deepest question unanswered. What color was Venus? What did that hellish landscape truly look like beneath its perpetual clouds? The photometer had hinted at brightness, but hue remained a mystery. The program's ambition sharpened. They would return, with better cameras, stronger cooling, longer survival. 7 years later, one lander would finally open its eyes to a sky no human had ever imagined. On March 1, 1982, Venera 13 descended through the sulfuric clouds and settled onto the Venusian plain near Phoebe Regio. Everything about it had been refined by 7 years of hard lessons. The titanium sphere was sturdier, the insulation thicker, the electronics chilled deeper before the plunge. And this time, the cameras carried color filters, ready to capture what no eye had ever seen. The lander touched down and immediately began its work, ejecting the protective lens caps and swinging its scanning cameras across the landscape. What the images revealed stunned the scientists in the receiving stations. The sky was orange. Not blue, not gray, but a deep amber glow. The sunlight filtered through 100 kilometers of dense carbon dioxide atmosphere, until only the warm end of the spectrum survived. The ground itself was orange-brown, littered with flat, fractured slabs of rock, stretching to a close horizon. It looked like a photograph taken at the bottom of a furnace, and in a sense, it was. Venera 13 endured far longer than its predecessors. Where Venera 9 had lasted 53 minutes, this lander operated for 2 hours and 7 minutes, more than doubling any previous survival. Every extra minute was a battle against the 465-degree heat and the 90-bar pressure that squeezed the sphere like a fist. During those 2 hours, the cameras completed multiple panoramic sweeps, alternating color filters to build full-color views of the alien terrain. A mechanical drill extended, bored into the surface, and pulled a soil sample into a sealed chamber for chemical analysis, all while the electronics slowly cooked. The color panoramas transformed Venus from an abstraction into a place. Scientists could now see texture, tone, the way light played across the broken plates of rock. They saw the lander's own equipment resting on the ground, a piece of Earth sitting in an environment that would destroy any human in seconds. Then, as always, Venus won. The temperature breached the limits, the systems failed, and Venera 13 fell silent. But it had left behind something extraordinary, a color window into hell that demanded to be read and understood. The panoramas and soil data from Venera 13 became a text that scientists spent years decoding. The color images showed a surface of layered, platy rocks, thin slabs stacked and fractured across the ground. Their appearance suggested volcanic origin, basaltic lava that had cooled, cracked, and weathered, under conditions no laboratory on Earth could reproduce. The flat, broken texture hinted at a young, active geology, a world shaped by heat and pressure, rather than water and wind. The drilled sample told an even deeper story. Venera 13's onboard X-ray fluorescence spectrometer analyzed the soil delivered into its sealed chamber and identified the chemistry of the Venusian crust. The results matched lucite basalt, an igneous rock rich in potassium, confirming that Venus was a volcanic planet with a composition broadly similar to Earth's volcanic regions. For the first time, humanity held a chemical fingerprint of another planet's surface, gathered from a location that would kill any explorer instantly. The photometric data refined the picture further. The orange light was not a camera artifact, but a genuine feature of the environment, the product of an atmosphere so dense that blue and green wavelengths scattered away before reaching the ground. Scientists calculated that only a fraction of sunlight penetrated the clouds, yet enough remained to read the landscape clearly. The absence of shadows in the images spoke to the diffuse, scattered nature of that light. A world lit evenly by a glowing sky rather than a visible sun. Together, the geology, chemistry, and light measurements built a portrait of Venus as a coherent place with its own history. Engineers and geologists studied a world no human could ever walk, mapping its rocks and reconstructing its volcanic past from fragments captured in minutes. Each detail deepened the understanding of how a planet so close to Earth in size and composition had become so utterly hostile. The Venera landers had done more than survive. They had performed field science on the surface of hell, gathering data that reshaped planetary science and stood unmatched for decades. And in doing so, they raised the final question the program's legacy would answer. What had this audacity truly accomplished? The Venera landers were built to die. Every engineer who designed them knew it. accepting from the beginning that their creations would function for minutes and then be crushed and melted into silence. That acceptance was not defeat, but strategy. Rather than attempting the impossible task of building a machine to endure Venus indefinitely, the Soviet teams designed for a brutal, brilliant compromise, pre-cooled spheres of titanium racing a clock they could never win, engineered to steal just enough time to change what humanity knew. The audacity of that approach still astonishes. Between Venera 9 in 1975 and Venera 13 in 1982, the program advanced from a single 53-minute black and white glimpse to 2 hours of color panoramas and chemical analysis of the soil. Each lander built on the graveyard of its predecessors, transforming failure into knowledge, loss into capability. The engineers learned the true scale of 90 bar pressure and 465-degree heat, not from theory but from wreckage, and they answered it with insulation, cooling, and spheres shaped to defy the crush. What they achieved has never been repeated. No spacecraft since has photographed the surface of Venus. The images those doomed landers returned remain the only color views ever captured from that world. Decades old and still singular. They showed an orange sky, fractured volcanic plains, and light filtering through an atmosphere that would extinguish any life in an instant. They proved that the surface of the most hostile planet in the inner solar system could be seen, sampled, and understood. The legacy of Venera is a lesson in ambition measured against impossibility. The program did not conquer Venus. Venus won every encounter, destroying each lander exactly as predicted. But in the narrow window before destruction, those machines accomplished something permanent. They reached across the impossible gap between Earth and Hell and brought back proof. The landers are gone now, corroded fragments somewhere on that burning plain, but their images endure as monuments to what brief survival can achieve. In the end, the story is simple, and it is extraordinary. They photographed hell and survived minutes.